Hello, everyone. We're back from the lunch break and networking sessions. The networking sessions for today are over. We've had some very interesting topics that we covered today. And I urge you to come back tomorrow and join us on Discord. You have the Discord on our website. And just socialize with people, because conferences are also the very important part about conferences are the talks, but also the socialization aspect. So we hope to see you there tomorrow. Next up, we're kicking off the second block of talks. And now we have Marina Marjanovic with us, a professor from the Singidunum faculty. She is talking to us today about, can computer read human emotions and change them? Hi, Marina, how are you?
Hello, thank you for introducing me. I'm fine, thank you. I hope that you are fine too.
Yeah.
Nice to meet you, at least virtually, and I hope that we will have opportunity to see each other in.
Yeah.
Yes.
Maybe next year.
Nice.
So in her talk, Professor Marina Marjanovic will discuss computer vision applications in human-robot interaction with a focus on affective computing. She'll present her research on human behavior analysis, and it's being used to improve human-robot interaction. It is a very complex and delicate topic, but an important one for the future of AI and technology in general. So Marina, you can kick off the second block of talks for today. We are all very eager to hear what you have to say.
Thank you. As you said, for today you presented the topic, can computer read human emotions and change them? And this is related to human behavior analysis that is used for human-computer interaction. And for this presentation, I chose some of my projects and some of the projects of my colleagues that I'm collaborating with. This is technical faculty, Technical Institute from Tartu in Estonia and University Autonoma from Barcelona. We did many researches related with image processing, and selected projects that I will present you here are human interaction enhancement using emotion recognition, and also age estimation briefly, that it is like our future research. Also, in this presentation, I will present you some databases that we used, and many of them we created by ourselves, that are used for emotion recognition. And I will explain you how, under which conditions are those databases are created, which experiments we did in order to capture some emotions, which emotions we chose. Also, I will present you some interesting papers that we or some other people done using these databases and their results, and also including their models. And also I will present the results that are achieved, and I will present you our future ideas about future research. So if anybody is interested for this topic, we are very happy if you can join us and we can collaborate together in this field. As I said, this emotion recognition belongs to human behavior analysis. And the human behavior analysis in general has a wide spectrum of applications. So, for example, in this slide, it is presented for ATM machines, then gesture recognition, and many other, also for the security and for any application that requires face or voice recognition. For example, also we are developing one project for working like human-computer interactions, developing robots and software for interaction with children with autism, and also for working with elderly people, how to interact with, to improve their social lives. And for this, of course, emotion recognition is necessary. There are 7 basic emotions that are given by psychologist Paul Ekman, and they are anger, contempt, disgust, joy, fear, sadness, and surprise. On this photo, when you see those emotions, they are too obvious, and they are like anger 100%, contempt 100%, and there is nothing behind this. And the question is, are those emotions are realistic, yes or no? So most of the databases that are presented on internet that you can download are acted emotions, so they are not genuine emotions. There are many reasons for this. First reason is that you need to have some legacy rights for the people that you want to capture emotions from. So it's not so easy to convince somebody to capture some emotions when the person is angry or sad, or even if you say to the person that you will record his emotion and to capture some video, this emotion stops to be genuine. So there is a lack of genuine emotions databases. Also, there are some emotions, those 7 emotions are not enough. How many times you were angry and sad in the same time? You were sad and happy at the same time. You were surprised and scared at the same time. So those emotions are obviously not enough. And in this presentation, I will present you some databases developed for this purpose, and to create such databases that are genuine, to show the difference between genuine emotions and fake emotions, to make some data, to show you I will show you the database that it is created for some contemporary emotions, then also the database for the blocked emotions, because some of the negative emotions like anger, when somebody is angry or sad, people are trying to hide. So for this purpose, we created one database that is database for hidden sadness, where we wanted to detect some micro expressions and to detect such negative emotion. Okay, for all of them, the same scenario was used. Camera was around 1.5 meters, white or light green background, and this scenario is used for creation for all the databases that we used. Of course, the better resolution of camera, then the database can give us the more accuracy and more space to work on. And also, uniform lightening condition was very important to be stable, not to be changed, and to be changed. And resolution of the image were this, but it doesn't mean we had some old databases that had worse resolution, but it didn't stop us to make experiments on them. First database that I will start with is a database for complementary expressions, because human-computer interaction experience becomes more realistic if the computer is capable of recognizing more detailed expressions of the human who is interacting with it. And there is a big barrier in front of the scientists who are working in this field, and the lack of facial emotion database, including detailed emotions such as, for example, surprisingly happy or fearfully sad, And for to make these frames labeled, of course, expert help from expert like psychologists is necessary. And this is one of the problems of this, because this is a long process for psychologists to label all these data frames, and for this it's very time consuming. This database is created in technical faculty of Estonia, where this database is developed for for complementary emotions that I mentioned. And if you look at those images, it's in compared to the Paul Ekman database, not database, but Paul Ekman definition of 7 basic emotions. It's not so easy to classify them like one of them. This is because all these images contain emotion that it is something between two of them. So in this database, we have 250 facial expressions, where 125 subjects was participating. And for all these databases, we are trying to have uniform distribution between gender, and also to have some age range that we can, if we don't want to ask, of course, to classify emotions that are age dependent. So we are working with students. So this is age from, for example, 20 till 35. And in this database, each subject acts 50 different emotions for each of the basic emotions. So 5 samples are for each person are taken with Canon camera under, of course, uniform lighting and with some good resolution. So if some person had trouble in expressing some emotion, common traits were given. For example, the explanation to the person that how to look contempt to have, for example, thinner links, and the combining of emotion was left up to the subject themselves, how they are expressing their emotions. And for this purpose, people were some of the emotions were genuine and some of them were fake, because it's not so easy to make the person angry if he's participating the experiment. But they also did some funny things, not funny, but for example, they were also allowed to break somebody's glasses to make him angry, and after that, of course, they bought them new. But it was very important to provoke as more genuine emotions as it was possible. And so to create this kind of emotions, important thing is, for example, if you wanted to, I will just show you. It's not here. Never mind. How to, for example, provoke? It is easy to generate some emotion, like from Paul Ekman. From Paul Ekman definition, like angry, contempt, disgust, but or fear, or happy, or sad, and surprise. But this some between emotions were, for example, if the person was happy, how to make the person angry after this moment, or if the person was sad, how to make this person sad. So depending which dominant emotion was, the other emotion was bringing the effect of the complementary emotion. So using this experiment, all these classes of emotions were developed, and I will show you how they look on this image. For example, this person is sadly happy, because the main emotion is sadness, and happiness is also provoked after, or sadly surprised, surprisingly angry, surprisingly fearful. And all these emotions were really deeply analyzed by psychologists, and they were labeled before using them for the experiments. So here are all some samples of those emotions. For example, this is pure happiness, and this is pure sadness, and this is pure surprise, which are more obvious than, for example, angrily disgust, angrily fearful. So you can see the difference between those expressions. And for us who are not experts in psychology, it's difficult to distinguish them or to define them as some experts did. And one of the papers that was done in where this database was used was represented on Face and Gesture conference in 2017, where on one hand the landmarks from the face were extracted, and on the other hand the frames were used to feed the convolutional neural network that had this architecture. And the upper part is this single branch convolutional neural network. And this on the landmarks, 68 landmarks of the face, one more input is added to the classifiers within the architecture of this neural network within one layer. So this architecture was slightly modified using these landmarks, and around 20% of accuracy was obtained. 20% of accuracy doesn't sound so high, but considering this amount of classes, this amount of emotions, 20% of accuracy is a pretty good result. The second database that it is created is a sequential emotion database, where transitions between different facial muscle states was created in the emotion changing. And each person is typical and unique by changing from one emotion to the other emotion. And in one of the papers, it is proved that this could be used as some biometric input to recognize this person, because two people can be similar, but the way they are changing from one emotion to the other can be used as a fingerprint or voice, or better than the pure face recognition. So to make this database, 4 basic emotions defined by Paul Ekman were used. And the emotions like fear and disgust are not used, because it is shown that they are more difficult to mimic these kind of emotions. And each of the basic emotions was recorded around 3 seconds, after which the subject were notified to move on the next emotion. So, for example, how the database is created, people were, for example, 3 seconds happy, and after that they changed emotion to be sad. Of course, this was not genuine emotion. They were fake, but for this purpose, this is good. After, or for example, to change from sad to be surprised, or disgust after being happy, sad after being happy, angry after being happy, and so on. And also on the face and gesture recognition in 2018, 18, the paper is presented that it is shown that these facial dynamics, how landmarks are changing, can be considered like unique signature for discrimination between people, and extracted also for this purpose the landmarks from the face, and also video frames were used for fine-tuned VGG, convolutional neural network. And this model, the temporal context, because the landmarks are changing their position. So context of the transition frames, long, short-term memory on the geometric and convolutional neural network features they were trained. I will show you after the block diagram. And after this, after using both frames and landmarks, the two fusion strategies were applied. One fusion strategy was on feature level, called early fusion, in which the geometric and the CNN features were stacked and fed to this long short-term memory. And experimental results show that delayed fusion strategy on the result level, after getting confusion matrices, gives the best results, and the transition frames give better identification result between people. So here is the proposed model, using landmarks and convolutional neural network. And after the fusion was done on the feature level, they were concatenated, and after that, those features were fed into the long short-term memory. The better solution was this one, when first we applied the convolutional neural networks were applied to the data frames and long short-term memory, and after that, on block distance feature, also they were feeding the long short-term memory, and those results were fused, and support vector machine model was given, and the output was better. The precision was better than in the early fusion. Here are some recognitions, like prediction of the long short-term memory trained independently on two features. And so here is the recognition, like changing from emotion neutral to happy. So these columns represents like transitions between two basic emotions. One of the, again, interesting question is that there is a lack of genuine emotions, and how to recognize them. On this photo, it's Julia Roberts is presented, and on the left, I guess that you can recognize what is fake versus a real smile. And if you observe the left image, you can notice that on the left image, there is a lack of eye muscles contractions, and on the contrary, when the genuine smile is, there is this contraction. And for this, I will a little bit speed up because I have 15 minutes more. So for this database, there is a video set created from 50 subjects, and for each subject, there are 12 videos representing 6 basic emotions. So anger, happiness, sadness, disgust, content, and surprise, for real and fake emotions. So each video was recorded around 3 and 4 seconds. So with high also resolution camera with 100 video frames. So in order that subject express these emotions, they were shown different videos that could provoke the genuine emotions. And they were also asked to perform the same emotion, but in the fake way, if they didn't feel it. Or, for example, to record fake surprise, they were calling disgust video and ask person to act surprise, to be as more fake as possible. So here are some. So again, for to each person, all those emotions were truly explained, and these videos were simultaneously shown, like to evoke different emotions. Different stimulus videos were shown to provoke anger, happiness, disgust, sadness, and surprise, and this was this experience for this, and the output was the database created. And for this, you can see that people are repeating. It means in some of them they have genuine emotion, and on some of the photos they have fake emotions. So for this purpose, here it is represented like anger, fake anger recognition, and the proposed model was to use also image sequences, facial landmarks, and for with facial landmarks, temporal trajectories was used, and and the output of the convolutional network neural network were convolutional neural network feature space. So here is a fake happiness activation map, where the evidence in experimental psychology shows that discriminative facial responses are short and subtle, and this suggests that such a behavior would be easier to distinguish when captured in high resolution at increased frame rate. And it is shown that accuracy to detect genuine emotion is much higher than accuracy of acted emotions, of unfelt emotion. And here are some results of for each emotion, what was the accuracy for genuine and accuracy for unfelt emotion. So according to this result, it is obvious that, for example, genuine happiness, it's the most easy to detect. And, for example, the most difficult emotion to detect is contempt. And also everything is worse for the unfelt emotion, for the fake emotion. Other database, I will just briefly go over this, is that we wanted to develop the database of emotions that are not so obvious and that person is trying to hide. And usually people are trying to hide some negative emotions like disgust, sadness, or angriness. So this also could have a very big issue for the application, for example, for biometric, to understand, for for psychologists, for example, to detect is the person talking to you feel stressed, or to work with children with autism or people with autism, where it's difficult to detect the presence of any emotions. And or on for example, for human resources purpose, if the HR wants to detect if the person in front of him or her tries to impress him without feeling what he or she talks about. For this purpose, just trying to detect one emotion like sadness, we developed a database with blocked emotions, where we had random, we have uniform distributions between subjects, where students without knowledge, they were alone in the room and they were watching some sad videos, and knowing that they will leave this room, and being with other group of colleagues, they were trying to hide the sadness. And on some these frames were labeled also by psychologists where the presence of some blocked of some micro expressions were detected. And you can see here some blocked emotions for male and female, neutral, like when the person doesn't feel any emotion, and obvious sadness when the people was not hiding how he was feeling. The model that we proposed was we extracted using open face code 68 landmarks and eye gazes, and also on the other hand we extracted video frames. With the data sets, we also separately observed all face region landmarks and also eye gaze region landmarks. And we showed that using eyes region landmarks, including eyebrows and eyes, we were able to detect all these micro expressions that they were used by these subjects within the experiments. And after that, on the landmarks, we applied support vector machine and render forest, and on the frames, we applied convolutional neural network, and we achieved accuracy like 80%. Okay, I will not show. I want to present you one more paper, and I will leave the space for the questions. We are also working on multimodality, estimating the emotions from voice, face, and also students from software and data engineering showed you like EEG signal using Vitalino device. And in one of the paper in IEEE transactions in 2017, we introduced a novel multimodal emotion recognition system that was based using visual and audio modality. But for this purpose, we used standard database with 7 basic emotions. They were active, and we extract. In one hand, we extracted the geometrical features, and on other hand, we extracted video frames. And also we extracted around 90 features from the voice, where we used like the Mel-Septrum coefficients, intensity, pitches, and we created audio data sets where we applied some classification and achieved some result. Also, on the frames, we applied convolutional neural network and got some convolutional neural confidences. And on geometrical features, we used only 5 main frames. We applied classification using random forest and support vector machine and achieved some results. Those results from each modality were nothing so amazing, around 70, 80, 90%. But after fusing those results on the result level, we got accuracy that it's close to 100%. And we compared our result using, of course, the same scenario for train test splitting using our model. And we showed that we improved the other state-of-the-art results significantly. And this paper was published in IEEE Transactions on Affective Computing. Our future plans are to estimate the emotions and its relationship with gender, to detect who is who is more obvious showing the emotions and with which part of the face. And also we want to estimate the emotion recognition, but before this we want also to do the age recognition, and so to see how the expressing of emotions is dependent on age. And this can be used for education and affective computing. For this, for example, for the age recognition, we will use our model for age estimation that it is presented at the VGG 16 conference, where we achieved good results, including bias that it is bringing, for example, the presence of the light or the difference from the old picture or new picture, how this is influencing on the age estimation, and adapting VGG neural network in one layer using this features, and we achieved a pretty good result for the age estimation, around 92% accuracy. Okay, I think I am now in 4:10. My presentation should be finished, so I guess that we have time for some questions. So please ask me, and thank you for your attention.